Dear students, this is Dr. Biju Devan. In this video, we will discuss chapter 13.1 separable partial differential equations, which follows on week number 13. Separable partial differential equations. Introduction. Partial differential equations, like ordinary differential equations, are classified as linear or non-linear. So, analogous to a linear ODE, ordinary differential equations. The dependent variable and its derivative, partial derivatives, appear only to the first power in a linear differential equation, linear partial differential equation. So here we are concerned only with the linear partial differential equations. So what they mean to say, if I say y is a function of x and t, x and t are independent variable, dependent variable, isn't it? Y is called a dependent variable. Now they are talking about the dependent variable, right? So yx means y derivation with respect to x, y first derivation of y with respect to t. This is called dou y over dou x partial derivation, dou y over dou t. We can write y double x, y double t, or y xt, or y tx, isn't it? Or if I write a differential equation, y double x plus y double t is equal to 0. This is a linear partial differential equation. The y or its derivatives, y square and yx square should not appear there. The derivative of y or y itself should not appear in higher degrees. That's the condition here, right? So linearity, that's what linear partial differential equations. The general form of a linear second order partial derivation has been given. This is not degree, this is derivation, second derivation. You can write a u x x. U has been given as a function of y. U is a function of x and y, now two variables. A times uxx plus b times uyy plus c times this is c, this term is here, b times uxy, d, this is c, this is d, okay. D ux e uy plus f times u is equal to g. Right side is also function of c. See, all the coefficients a, b, c, d, e, f, g, h are constants or functions of xy. They are allowed to be functions of xy. When the right hand side is 0, we call it homogeneous. Otherwise, this differential equation is non-homogeneous. So this is the second order, general form of a second order differential equations, right? Second order partial differential equations. Okay, linear second order partial differential equations. When you take d, e, f and g are zeros, a is 1, b is 1 and c is 1, then you will get a differential equation uxx uyy plus uxy is 0. So from the differential equation we can find the coefficients, the value of a, b, c, d, e, f, g, h, you have to g. Clear? Here it gives second derivation of the coefficient of the second derivation with respect to x will be called a. Coefficient of the term uxy, first derivation with respect to y, second derivation with respect to x. Otherwise, different order, no problem. Okay? The coefficient of this derivative will be b. Second derivation with respect to y, the coefficient of this term will be c, and first derivatives. So in this way you should identify the coefficients of the differential equation. Now here from this one, what do you identify? What is the a value and b value? A value uxx, the coefficient of this one is a is 1, and this c is 1. Go back, when you differentiate with respect to y, the coefficient twice, the coefficient is c. So c is 1. All other constants are zeros for this one. Here a is 1, c is negative, no, it's not c. What is this? C is not c. C is second derivation. This is e, this one. the coefficient of dou u by dou y, which is e. So e is -1, all other constants are zeros. Some examples of linear second order partial differential equations. The first one is homogeneous because the right hand side is 0. The second one is non-homogeneous, which is a function of x and y. Okay. Now in this chapter we are concerned about finding particular solutions of some of the important linear partial differential equations, the concern of this chapter. But that will be done in this chapter. Separation of variables. This is important. What we are going to do in this chapter is this one. Although there are several methods that can be tried to find particular solutions for a linear partial differential equation, the method of separation of variables we seek to find a particular solution of the form of a product of a function of x and a function of y. That is, we are going to assume u is equal to x into y, where u is a function of both x and y, x is a function of x alone, y is a function of y alone. That is, we are separating the entire function to two parts. One is a function of x alone, another is a function of y alone, and then we use a different technique to solve it, isn't it? Here what you find here, when you differentiate u with respect to x, you are differentiating only x part, x prime, y. Now x is derivation in the ordinary differentiation. If you want to find u y, when you differentiate u with respect to y, you will find x y prime. So when you differentiate x, ux again uxx, which will be x double prime, y will not be differentiated partially, isn't it? So that's what given here. Ux is x prime y, uy is x y prime, u double x is x double prime y, u double y. From this one we can find u double y, which is x y double prime. And by using this derivatives we can separate the variables. So this method of separation of variables, right? Okay, superposition principle is another important rule that may be useful in solving the problems. What they come to say: if u1, u2, uk up to uk, there are k's or there are k terms, are the solutions of a homogeneous linear partial differential equation, then the linear combination of all these things together will be yet another solution of the problem, same problem. That's superposition principle. We may use this result in coming problems. Now, classification of equations. How to classify based on the, this is the based on the values of the coefficients. This is the given second order linear partial differential equation. If we know the values of a, b, c, we can classify the equation. See, if b square minus this discriminant b square minus 4ac, b square is this this term, the second derivative term in which involves both x and y, take the coefficient of b, this term which is b, and square it, multiply a and c, subtract the from. So if b square minus 4 times ac is positive, then we call this differential equation hyperbolic. If this determinant is equal to 0, we call the differential equation parabolic. If this determinant discriminant is elliptic, we call less than 0, we call this differential equation elliptic. There are three cases: positive 0, positive greater than 0, equal to 0, negative less than 0, isn't it? So if positive is hyperbolic, equal to 0 it is parabolic, less than 0 is elliptic. Only three cases, right? No other constants necessary for this classification. Okay, now the first problem is to use separation of variables method to find the solution of this product solution. We call it product solution for the given partial differential equation. So this is nothing but ux is equal to uy, isn't it? Now let u is equal to xy, product of x and y, assuming that the solution u for this differential equation is the product of a function of x and a function of y, isn't it? Product of two functions. Now u prime, ux, when you differentiate this equation with respect to x alone, you will get x prime y, and u prime uy, when you differentiate this y alone, x will not be disturbed, uy. We will use this one in this equation. So this is ux is x prime y is equal to xy prime. Now club the x's on the left side and y in the right side. X prime over x is equal to y prime over y. This is what we get. Since these two are equal, we take it equal to negative lambda. This is our assumption. We take negative lambda a constant, isn't it? So when we take negative lambda, this is our assumption. We are comparing first and last term first. X prime over x is equal to minus lambda, which will give you x prime is equal to minus lambda x. And when you take to the left side, x prime plus lambda x is equal to 0. This is the first order differential equation whose solution is known. The solution x is, we know x, capital X is a function of small x, so x is c1 into e raised to minus lambda x. This is capital X. So the solution of this problem, this differential equation. And now go with the second part. Compare these two. I'm going y prime over y is equal to minus lambda. So do the same work. Cross multiplication. Y prime is equal to minus lambda y. Y prime plus lambda y is equal to 0. This is the first order differential equation. Linear differential equation, isn't it? So its solution is known. Y is c2 e power minus lambda y. So we got x and y. So the solution is u is equal to x comma y. The solution, the particular solution we are writing. Particular solution is u, which is x into y. c1 into e power minus lambda x, c2 into e power minus lambda y. Now c1 and c2 are constant. Multiplication is yet another constant called the constant c. Now we can club the remaining terms. E power minus lambda is common, x plus y. Condition lambda not equal to 0, because when lambda is equal to 0, it's not equal to this equation. So lambda not equal to 0. That's the solution of this problem. Let's go for the second problem. Problem number 4 from your textbook. ux is equal to uy plus u. Okay, let's take it as let u is equal to xy. Obviously we will find u prime, which is ux we will find ux will be x prime y, and what is uy? Xy prime. Now substitute them in this equation. What do you get? Ux x prime y, which is equal to uy is xy prime and u is xy. So xy, x prime y in the left side, x is taken as common from the right side, which is y prime y. Now x is in the left side, x prime over x, this x is divided on the left side, this y is on the right side, y prime plus y over y. When these two are equal, we make it equal to lambda, and we are assuming it's equal to another constant lambda. Now compare these two and again these two, find two solutions using this equation. That will be your answer. X prime, for first order is easy, x prime over x is equal to negative lambda. Therefore x prime plus lambda x is equal to 0. The solution of this kind of equation is no, x is c1 into e raised to minus lambda x. So we got x, we have to find y. Compare this to y prime plus y is equal to minus lambda y. So the coefficient of y is so should be carefully taken. Y prime plus y plus lambda y is 0. Y prime plus 1 plus lambda times y is 0. Instead of lambda we have 1 plus lambda, that is all. So the solution of this kind of differential equation is y is equal to c2 e power lambda. Instead of lambda we have 1 plus lambda minus 1 plus lambda y. Alright, so this is the solution, and I believe you know the solutions of this kind of differential equation. If not, check the introductory page of chapter, what's the chapter? In the case of what I said, for the sum level problem we have seen some solutions in the first page. You can check that one, there you can find this kind of solution. Otherwise you had to personally solve this one. So the solution is known, I'm writing here. Now final solution I'm writing, u is equal to xy. So what is u, what is x? c1 into e power minus lambda y, c2 into e raised to minus, right, c2 into e raised to minus 1 plus lambda y. c1 c2 are constants, multiply them together you get another constant c e raised to minus, rearrange the terms, e raised to minus lambda y, this one is minus lambda y, minus lambda x, minus lambda x, minus y, minus lambda y. So c into e raised to minus x plus y lambda and minus y. That is the solution of this problem. We are going for the next problem, problem number 5 from the textbook. From the textbook, right? Again the same concept will be followed. What is it? Let u is equal to x and y, ux is equal to x prime y, uy is equal to xy prime. Use them in this equation. Number 1, what do you get? X times ux, x prime y is equal to y times uy, xy prime. So when you club the x together you will get x, small x, x prime over x. Small x the independent variable, capital X is the dependent variable. Remember it is okay. Capital X is the function of small x, which is equal to y prime over y, which is equal to negative lambda. This is our assumption. See. Okay. Now compare the first and the last. What do you get? Small x, x prime over x is equal to minus lambda. So small x, x prime plus lambda capital X is equal to 0. This is the first order differential equation with variable coefficient, and you know how to find the solution for this one. What is the solution of this kind of equations? I'm writing here y is equal to it's x is equal to c1 x power minus lambda. Check the first page, the solution is available. We have discussed this kind of solution in the chapter stem level problems, isn't it? Check the first page. And if you are not clear, at the end of this one I will explain how to find the solution of this kind of problems. Second problem, compare these two. What do you get? Y prime which is equal to negative y, so y prime plus lambda y is equal to similar type question term. So y is, this is independent variable, so the answer y is c2 times y power minus lambda. This is small y. These are the two solutions. So final solution, u is x into y, which is c1 x power minus lambda, c2 y to the power minus lambda. You will get c1 and c2 becomes a c x y to the power minus lambda. This is the final solution of this problem. And when there is a variable coefficient for a first order differential equation, how do you solve it? That will be discussed now. I'll show you a differential equation. X y dash plus lambda y is equal to 0, where y is a function of x. You understand? Y is a function of x. What happens now? That is, this is x into dy by dx plus lambda y is equal to 0. Okay. Now what we are going to do is a new variable. I introduce theta, which is d by dz. So if I write theta y, it is dy by dz instead of d. So what I am going to do, theta is derivation with respect to z. Now let x is e power z, which will give you ln x is equal to z. We are changing the variable. So when you want to write this one, this is so when you want to find dy by dx, the formula is d is a function of y is a function of z and z is a function of x. From this one, when you differentiate z with respect to x, you will get dz by dx is 1 over x. So here dy by dx will be expressed dy, this one, it's theta y, and this one will be 1 over x. So multiply x to this side, you will get x into dy by dx is equal to theta y. So the equation number 1 will turn into this one and turn into theta y plus lambda y is 0, theta plus lambda y. This is the first order differential equation with the constant coefficients. The solution of this kind of function is y is equal to, you can say auxiliary equation is theta plus lambda. I can call it m plus lambda is equal to 0, m is minus lambda, so only one m. So the solution is y equal to c1 to e power mx, isn't it, which is c1 to e power minus lambda x. But e power x, c into e power x to the power minus lambda, but e power x is our assumption. Where is it? This one. What is e power? So this should have been in z, because now y is theta is differentiable with respect to z. So answer is z. This will be e power z. E power z becomes x. So this is the way you get the answer, c into x to the power minus lambda is a solution. So in this way, actually the procedure I have explained how can you assume the solution y is equal to c into x power minus lambda. Okay, note it down. But we are directly using this results in this problem. Problem number 5 has been solved. Problem number 7 now. Take u is equal to xy. we want second derivative is ux x prime y, u double x x double prime y, and what is uy x y prime u double y x double prime x y double prime. From this one we can find u x y, differentiate this result this one with respect to y, so which is x y double prime. With respect to this is already y, so we are differentiating this one with respect to x. The answer here is x prime and y prime. When we substitute all this in the equation number 1, what we get? First time u second derivative x double dash y plus second term x prime y prime x y double prime is 0, and this cannot be further separable, so we can write this is not separable. Cannot separate x one side and y one side, so we can stop this problem here, right? The next problem is problem number 12 from the textbook. The same strategy we have to follow. Same strategy. Problem number 12. Let's check what we get here. Assuming u is equal to, here u is the function of x and t, not y, x and y. So u is capital X and t. ux is x prime t. u double x is x double prime t. Similarly, what is ut is equal to x t prime. U double t is equal to, do we have u double t? Yes, this time is u double t. U double t is equal to x t double prime. We don't have u x t, isn't it? Only 3 times. Substitute in this equation number 1, what you get? A square x double prime t is the first term is equal to u, that is x t double prime plus 2k times ut, this one, x t prime. Okay, this is what we got. This is a square, so I write it again. No, I rearrange terms actually. I will take x from these 2 terms outside, so a square x double dash t is equal to x times t double dash from plus 2x t dash, isn't it? Now take this x to the left side, t and a square to the right side. X double prime divided by x, this is equal to t double prime plus 2kt prime divided by a square t, which is equal to, considered to be negative lambda assumption, right? Now this is what we got in the first step. Next, assuming this is equal to this one, finding the solution, this one, and this one is equal to this one. Now here assume you identify these are second order derivatives. First comparison, x double dash over x is equal to negative lambda will give you x double dash plus lambda x is equal to 0. This is a second order linear differential equation, which is almost in this Sturm level problem without boundary conditions, isn't it? And we have to analyze the solution of this differential equation for 3 cases: lambda less than 0, lambda greater than 0, and lambda equal to 0. We don't know what is the case of lambda, isn't it? We'll analyze. We'll be back to that one. And I will compare second part, t double prime plus 2k t prime 2k t prime over alpha a square t is equal to negative lambda. Now this one multiplied right side, t double prime plus 2k t prime is equal to negative lambda a square t. And sound them up. When you take this term to the left side, t double prime plus 2k t prime 2k t prime plus lambda a square t is equal to 0. This is second order differential equation in t. Again the parameter is lambda. This can be rearranged to sum level problem. Okay, this one here again we want this lambda to be analyzed for negative, positive and 0. So simultaneously we will take, when lambda is negative, we will analyze this problem and this problem, find them solutions and write one solution for lambda negative, similarly for lambda positive and 0. Okay, and now I open this white page so that we can solve this problem on this one. Now I write the differential equations. The first one is x prime, let me write the size. Okay, x prime, x double prime plus lambda x is equal to 0. Another case is t double prime plus 2k t prime plus, what is it, plus lambda a square t is equal to 0. Now case 1, for both the problems what we are doing, case 1, lambda is equal to 0. I am taking easiest method first. When lambda is equal to 0, this will be x double dash 0. So the solution is x is equal to c1 x plus c2, because one integration will give you c1x, another integration will give you c1 plus c2, isn't it? Okay, so this is x. Here we will find when lambda is equal to 0, what we get, t double prime plus 2k t prime is equal to 0, and the auxiliary equation is m square plus 2k m is equal to 0. M is outside, then m plus 2k is 0. The solution is so the case is m is 0 and m is minus 2k. So the solution t is equal to, we can use different constants, c1 c2 has been used here, c3 e power 0 small t plus c4 e power minus 2k t, that is t is equal, this is e power 0 is 1, isn't it? So c3 plus c4 e power minus 2k t. This is the first case solution. So solution for case, under case lambda equal to 0, the solution u is xy, which is c1x plus c2 times c3 plus c4 into e power minus 2k small t. This is the way we are going to proceed for every case. Lambda is negative, then we will find solution in both the cases. We will write u. So it's not a unique solution. There are many different solutions for different cases, right? Next, go for next case. Lambda is let's have a choice, negative or positive. Let's go with the lambda is negative, and then finally we'll be back to lambda is positive. Now case 2, lambda is negative. This differential, so we will let lambda is negative mu square. So the differential equation becomes x double dash minus mu square x is 0, and the solution is known. You know, the solution is x is c1 into e power mu x plus c2 into e power negative mu x. This is the solution, because here auxiliary equation I can say m square minus mu square is 0, m is plus or minus mu. So m1 is positive mu, m2 is negative mu. E constant times e power m1x plus constant e power m2x. That is the procedure, isn't it? So this case, this is the solution for first problem. Second problem, what happens in the second problem? T double prime plus 2k t prime minus mu square alpha square t is 0. This is second order differential equation. So how to find the solution of this one? Assuming the auxiliary equation, what do you get? T double dash can be considered as m square plus 2km, first derivation is m, no t, isn't it? Minus a square mu square is 0. By using the formula x is equal to minus b plus or minus root of b square minus 4ac over 2, we will find m value here. So m is minus b. What is your b? Coefficient of m, 2k. So minus 2k. So write down here, a is 1, b is 2k, c is this term, c is negative a square mu square. Substitute in this formula, plus or minus b square 4k square minus 4ac. 4 a is 1, c is, so this will be plus a square mu square, isn't it? That is what is m. When you take 4 out of these two terms, it will be 2. So m is minus 2k plus or minus 2 k square plus a square mu square. And there is a division, divided by 2, and this 2 will be cancelled and commonly taken. So m will be minus k plus or minus square root of k square plus a square mu square. That is it. So there are two values for m. M is m1, I am writing m1 here. M1 is minus k minus root of k square plus a square mu square. It's not complex roots, they are real roots, right? As there is no negative sign inside here, there is no negative term inside the square root. So what is m2? Minus k plus under square root k square plus a square mu square. So how do you write the solution? T is c1 into e power m1x. E power, this c1, this is c3. Already c1 c2 used. E power minus m1, e power m1x minus k minus root of k square plus a square mu square times t plus c4 into e power minus k plus root of k square plus a square mu square times t. That's it. This is t. So the final answer for this case, u is x and t. You just write this one. We don't need to repeat them. Okay. So case 2 is done. Now we are looking for case 3. Lambda is positive. Lambda is positive. Case 3. Lambda is positive. So let lambda is positive mu square. Lambda is mu square. In the case, first problem will be, in this case, the first problem will be x double prime plus mu square x is equal to 0. The solution of this problem, you can assume m square plus mu square is 0, which is our auxiliary equation. So m square is minus mu square, m is plus or minus I mu. So alpha is 0, beta is mu. Therefore the solution x is c1 cosine beta mu x plus c2 sine beta is mu x. This is the format of the solution of the differential equation. For x it is done, but for second part, what is for the second t, problem of t double dash plus 2kt dash plus a square mu square t, lambda has been replaced by mu square, is 0. Just like the previous step, we will find m, which is minus k plus or minus square root of k square minus a square mu square. This won't be plus because the last problem, previous case, it was negative here, so it was positive here. Now it is positive here, you will get negative here, and 2 will be divided. Check the method. So you get m slightly different from the previous one. Here it is negative under the square root, isn't it? So it's depending upon the case whether inside the square root, the solution of the t is depending upon the term inside the square root. So again under 3 there are under this case 3, for t, finding the value of t, there are 3 cases. Now case 1, when the under the square root term is 0, k square minus alpha square mu square is 0. What is your answer? Then m1 and m2 both will be same negative k. There are 2 solution constants for second order differential. Therefore the answer t1 will be c1 plus t c3 plus t c4 into e power minus k. This is first case. And the second case here, sometimes case 2. Case 2, the under the square root term, the term under the square root is negative, that is k square minus a square mu square is negative, less than 0. Then we take it as a constant. We can take it as a constant p. I can take it. Then let k square minus a square mu square is minus p square. Therefore m will be minus k plus or minus I p. So for this kind of m, this is all complex pair, isn't it? Answer, I am writing this answer will be t is t2, this is t1, this is t2, e power minus k, alpha is k, e power minus k t, c5 cosine pt plus 6 sin pt. This is the second case solution for t. And again one more case, if case 3, enter the same case 3, if k square minus a square mu square is positive, we let k square minus a square mu square is equal to p square, and we can write m is minus k plus or minus p. So m on these are real roots. Minus 1 is minus k minus p, and m2 is minus k plus p. Therefore solution for this kind of solution term is t3 is c6 or what? How many constants have been used? C6 has been done. So 6C7 e raised to minus k minus p times t plus C8 e raised to minus k plus p times t. So there are three solutions for case 3 for t. Therefore the u is xt1 or xt2 or xt3 depending upon the case. That's the end of this problem. Okay. Now we'll go to the next problem from the PowerPoint. So the answers are given here in the PowerPoint, you can check. Problem number 16. Problem number 16. Similarly, you can check this one. U is xy. We want only ux and u double x prime y, u double x double prime y. Use them in this equation. So a square x double prime y minus g is equal to, right answer we have u. Of course this is not y, this is t, because the right answer is u t t. This is t. U should be function of x and t. So u t is x t prime, u double t is x t double prime. That is the right answer. You will get x t double prime. You cannot further simplify this one. This is x double prime t. So this is not separable. If there is no constant here, we would have tried to separate it, isn't it? So that's the end of this problem. Classify the given equations. Now classification, we have three classifications: hyperbolic, elliptic, parabolic. Hyperbolic, parabolic, elliptic. There are three cases to be carefully addressed, and we should remember the conditions. What are the conditions? Hyperbolic. What is hyperbolic? When the discriminant b square minus 4ac is greater than 0. Parabolic, when it is equal to 0. Elliptic, when it is negative, isn't it? Okay, take the coefficients. We should know what is a. The coefficient of u double x is, so problem number 17, a is 1, b is from here, u double x, u xy, b is 1 and c is 1. So what is b square minus 4ac? b square is 1 minus 4 into a into c is 1, which is negative 3 negative. The answer is elliptic for the first case. Problem number 19. What is a? A is from this term, the coefficient of this one is 1. B is from this term, b is 6, and c is 9. C is 9. So what is b square minus 4ac? B square is 36 minus 4 into 1 into 9, 36. It is 0. Then the answer is parabolic. Parabolic. Case 3. Let's start about 21. 21. What is this? u xx, u xy, only two terms. A is equal to 1, but when you take this term to the left side, b value is negative 9, not positive, isn't it? So c is 0. Continue with b square minus 4ac. b square is 36 minus 4 into ac will be 0. The answer is positive. Therefore we will write it hyperbolic. That's all. So when you want to classify the differential equation, you got to say either it is hyperbolic or parabolic or elliptic. That's all. That's it for this chapter. We will see the next topic in the next video. What's the next topic? This will be discussed in the next video. Thank you very much.